In this example, we're going to determine whether each percent of change is a percent increase or a percent decrease, then find the percent of change. So this is actually fairly straightforward. If our original number is 66 and the new number is 30, that number has decreased, so it's a percent decrease. And in the second example, our original number is 9.8 and our new number is 12.1, so that would be a percent increase. So right from the start, we can figure out which one we're talking about. And this is an easy example of each to try to see what we're doing. So this is going to be a percent decrease. This is going to be a percent increase. So right from the beginning, we know that. So when we do this, we want to use what we know to figure this out. Well, we know that when we write a percent, we're going to look at a couple things. The original number is going to be equal to 100%. That's the total, not the maximum. That's the total that we start with. So as we said in lesson 2.6, things that are related need to be either across from each other or in the same fraction. So I'm going to put 166, which is the original, across from each other. So I'm going to get 100 and the original in the same fraction. Then the new number is going to go on top, and then I'm going to figure out what percent that is. And so I'm going to use that to figure it out. I could have done this a different way. I could have written it so that we had new over percent is equal to original over 100. Remember, the things that are related to each other either go across in the fraction, either numerator, numerator, denominator, denominator, or in the same fraction, top and bottom, bottom and top. So 66 is 100%, so 30 would be related to whatever the new percentage that I'm looking for. And I'm going to give this a variable, and the first variable I'm going to choose is k. So when I actually do this, I now have a proportion. I'm writing this percent change as a proportion. I cross multiply and solve for the variable. So 30 times 100 is 3,000, which is equal to 66 times k. So now that I have 66 times k, I'm going to divide by 66 in order to isolate the variable. And what I end up with, the 66's cancel, what I end up with is 45.454545, on and on forever. So this is what k is equal to. In my other fraction, I know it's a percent increase. Well, before that, we recognize this is a percent decrease, and it makes sense to us. Okay? This new number that we're talking about is 45.45% of 66. If I did 0.45 times 66, I should end up 0.4545. I should end up with 30. Now we're looking at the original and the new for the increase. Again, my original is the 100. That's what I'm starting with. And my new is 12.1, and I'm looking for the percentage that 12.1 is of 9.8. And so when I do that, I'm going to give it a variable, standard variable of x. I cross multiply, so I get 9.8 times x is equal to 1210. So now I'm going to divide by 9.8 on both sides. When I divide by 9.8 on both sides, I get x is equal to 123.47. And I'm just rounding to 2 decimal places as a way to stop. This number continues to go on. It's arbitrary choice. As we continue on, we can see that this can be used not only in a straightforward problem, but in a word problem. So a recent percent increase in tuition at Northwestern University in Evanston, Illinois was 5.4%. If the new cost is $33,408 per year, find the original cost per year. So we recognize that we're talking about a percent of increase, which means the final number, the new number, should end up to be bigger than the old number we started with. But we have to look at what it is that we're doing here. So we have to think. When we start out in this problem, it says what? It says to find the original cost per year. Well, our original, we're going to give the variable because that's what we're looking for, always goes across from 100. Now, the common mistake would be to put 5.4 up top. But this is not the case. This question is not saying what is 5.4% of the original. This problem is saying that it's increased from what it used to be, which was 100%, and it increased 5.4%. So the percentage of the new amount that we're looking at is actually going to be 100, the original, plus the 5.4% that we had before to give us a total of 105.4%. And that's what's going to go on top. When we recognize that, we should see that that makes sense, right? We have 100% for the original, and then the new percentage needs to be bigger than the old percentage, right? The old percentage was 100. If it's a percent increase, the new percentage should be bigger. How much bigger? 5.4%. And so our new goes across from how much that percentage is, and that's 33,408. And now we're back to our standard proportions. Cross, multiply, and solve. So we have 33,408 times 100. 3340800 equals 105.4 times x. We're going to divide by 105.4 times x on 105.4 on both sides. And that should give us what the original amount of money these students were paying, which is still a large amount of money. And hopefully, if we did this correctly, our new amount of money that we're paying, and since it's money, it only goes to 2 decimal places, the new amount of money that we're paying should be less than the original amount of money that we paid should be less than the old amount of money, the new amount of money that we're paying. And that makes sense because we had a 5% increase. So we had an original amount of $31,696.39, and the new amount was $33,408. And that's a 5.4% increase. Martha was purchasing, so this also works in shopping, so we're looking at different ways that this is applicable. So Martha is purchasing wire and beads to make jewelry. Her merchandise was $28.62 before tax, so that's important, so I circled it. If the tax is 7.25% of the total sales, what is the final cost? Okay, and that's important. So we're back to where we started again. My original before taxes was 28.62. And so that's my original. It goes across from my 100. I don't know what my final is, because that's what they asked me to find, my final cost, so I'm going to put C. But I do know that tax is always added on to the amount that you had when you started. So that would be 100 is the percentage I had when I started, plus the 7.25% of increase, right? Because the taxes is being added on. Taxes don't make you pay less money, they make you pay more money. And so you have 107.25. And that's going to be the percentage of the amount that you pay after taxes are added in. Now we have our proportion. We're back to the same thing. We get 100C is equal to 28.62 times 107.25. That gives us 3,069.49 0.95. I'm putting one more decimal place because I'm not finished solving. I'm going to divide by 100 on both sides to get the variable by itself. And I get C is equal to $30.69.4, so it'd be 69 cents. We round down. And so, after taxes, you should pay more. How much more? 7.25% more, which means the total that we're actually paying is the 100 plus the 7.25.